Hi guys, Viva here from Bright Young Brains. So we're working on term 2 content, right? For now, we're specifically going to touch on cubic functions. So if you have not learned cubic functions before, this is generally new, right? So for grade 12, right, this is something that is going to be normal, right? We know that you basically have been working with quadratic equations where you basically start with where x squared is going that way. However, this year you're going to be working with cases where x is going to be to the power of 3 and then x squared and then x on its own and then something without x, right? So we refer to something in this format as a cubic function. So we know that whenever you need to solve quadratic equations, right, you could basically always use your quadratic formula. So the only key thing is that with your cubic functions, right, you don't have something like a quadratic formula that you can just plug things in and get a value for x, right? Unfortunately. So we're going to work on solving cubic functions, and we're also going to show how there are portions where you will need the quadratic formula, right? But then you will not use the quadratic formula to solve everything, right? So that's what we're going to touch on. So firstly, when you're going to be solving cubic functions, right, you will generally have three methods for grade 12 that you will normally use, right? So the first one will be common, you will basically need to look for common factors. And then another method, you could use grouping. And then lastly, you could use what we call the factor theorem. So we're going to work on all three of these, right? Starting with cases where you can use common factors, and then cases where you can use grouping, and then cases where you need to use the factor theorem. So you may already be familiar with using common factors to factorize and using grouping to factorize to eventually solve an equation, right? So what may be new is the factor theorem, which we said we're going to work on, right? So in a scenario where you will use common factors to solve a cubic graph, we can have an example that looks something like this. So for our first example, right, we're going to use common factors to solve for x. So here we can clearly see that we have each term has at least an x in it, right? So we can take that out as a common factor. And then this is what we have, right? So this has given us a scenario where we can split up our equation, right? So if we split it up, we'll basically have something like this or something like that. So we know that firstly we said x is just going to be equal to 0, or x squared plus 5x minus 14 is also going to be equal to 0. So we also mentioned that while you're solving for a cubic function, right, there are cases where you will be solving it and then you bump into a quadratic formula. You can use a quadratic formula to work out this portion. But then from the get-go, we don't have something where we can just throw everything inside, right? So at this point here, we can just use our quadratic formula to work out what x is. There we go, right? So there you would have used common factors to work out a cubic function. Very simple, right? And you can always bank on getting some of these here and there, right? Where you can easily just take out a common factor and then solve for x, right? Here we know that this is giving us our first solution. This is going to give us our second solution, right? Our second pair of solutions. So we know that this is just basically a quadratic equation. We threw that in the quadratic formula, worked it out, and we got x is equal to 2 and x is equal to -7. So with cubic functions, what you can also expect is you will start having scenarios where you can have at least 3 solutions. I mean, at most you can have 3 solutions. There are cases where you can also have 1 solution, and there are cases where you can also have just 2 solutions. So just keep in mind, if you're dealing with a cubic function and you need to solve for x, right, you can have 3 solutions. Cool. So for our next example, right, we're going to use grouping, right? So for us to use grouping, we will need to generally use a totally different sum, right? So for this example, right, we said we can use grouping to solve for x for this cubic function, right? So if we're going to use grouping here, we can clearly see that here we can take out x squared as a common factor. Here we can take out minus 9 as a common factor in order for us to get ourselves going so that we can solve for this cubic function, right? So if we do that, here x squared, if you take it out as a common factor, this is what you have left. Here we can take out minus 9 as a common factor, right? And then you also have x plus 2 left in your bracket. So the good news now is we know that here we have x plus 2, and then here we also have another x plus 2. So we know that for this expression and for that expression, these two have x plus 2 as a common factor. So we can take that out, right? You will have x plus 2 out, and then x squared will be left, and then minus 9 will be left, right? So we know that with grouping, all that happens is we know that 2 have something in common, which is x squared. These two terms also have something in common, which is minus 9, right? So if we take out something in common here, we have x plus 2 left amongst these two. If you take out what's common there, we also have x plus 2 left. So with your grouping method, this is a trend you want to look out for. You take out something common, you take out something common, and then whatever is left also needs to be the same. That you also take it out, right? And then you have x squared there and you have the minus 9 there. So this has been factorized nicely. This being factorized, you can now easily solve for x, right? Because here it just means that your first bracket, you're going to equate it to 0. Your second bracket, you're also just going to equate that to 0. So solving for x here, we know that it is equal to minus 2. Here we can clearly see this is the difference of two squares, and we know the difference of two squares the difference of two squares basically refers to x to the power of something, or rather a square value minus a value that's also a square number, right? So the difference of two squares, we will always be able to spot that if we have a value squared minus another value that's also a square number. So this being the difference of two squares, we know that we can split it up into x plus 3 and x minus 1, which will just give us x is equal to minus 3 or x is equal to positive 3. So another way to solve cubic functions is using grouping, right? These we will not get so many of them, but it's something you want to keep in mind, right? We say here these two have x squared as a common factor, these two have negative 9 as a common factor, so you can take those out and then factorize and then eventually solve for x, right? So it's another method which you are somewhat familiar with from grade 11. If you're not, we know that all that has happened is we looked out for something that is common amongst at least two terms, right? These two have something in common, these two have something in common, right? So we took that out here, we took that out there, and then because of your grouping method, you always want to look out for a trend that looks like this, right? So this will be one of your brackets, and then whatever this is and whatever that is will be your second bracket. So you would have factorized, right? After factorizing, you can just solve for x easily, which is in this case again also giving us 3 solutions, because with cubic functions we can generally expect 1 solution, 2 solutions, or 3 solutions, just like what we did here. So the next one is going to be somewhat new, right? We're going to use our factor theorem to work out a cubic function using a different example.